Welcome back, everyone, for another deep dive with us. Today, we're diving into the world of color.
Oh, fun.
It's going to be pretty interesting. I think we'll be using rules and curiosities about colors as our guide for this one.
Okay.
But we're not just going to, cover the basics. I think we all know what ROIG Buddy is at this point, so
Oh,
we're
yeah.
going a little deeper. We're going to uncover the hidden rules and the psychology, and maybe even some surprises about this colorful world.
It really is fascinating how much color impacts us, even subconsciously.
Yeah.
Our emotions and perceptions,
Yeah.
even our decisions can be influenced by something as simple as color.
Absolutely. So to start off, maybe we can lay down some groundwork.
Sure.
What are some of the fundamental rules of color?
But one of the most important things to grasp, I think, is the difference between additive and subtractive color models.
Okay.
So imagine you're looking at your computer screen.
Mhm.
That's additive color, also known as the RGB model, where red, green, and blue light are combined to create the entire spectrum of colors that you see.
Okay, but when we print something, that's a whole other process, right?
Absolutely. Printed materials use the subtractive model,
Yeah.
or CMYK, cyan, magenta, yellow, and black.
Ah.
And it's called subtractive because each ink actually absorbs certain wavelengths of light. So what we see is the reflected light.
So like mixing paints, for example, that gets more complex because you're kind of taking away light rather than adding it.
That's a great way to put it. Now, to build on that a little, let's touch on primary, secondary, and complementary colors.
Oh, yeah.
Remember those from art class?
I definitely remember mixing blue and yellow to make green.
Uh-huh.
It's
Exactly.
all coming back to me now.
Mixing those primary colors gives you the secondary colors. And then you have complementary colors like red and green or blue and orange, which sit opposite each other on the color wheel and create that strong visual contrast.
This is where it starts to get really fascinating for me, the psychology of color. Why is it that certain colors evoke such specific emotions? Like, why does red seem so energetic while blue feels more calming?
Well, there's a whole field of study dedicated to this called color psychology, which explores how colors influence our emotions and behaviors. It's not just a coincidence that fast food restaurants often use red and yellow in their branding.
They want us to feel hungry and make quick decisions, right?
Precisely. And think about how many brands use blue in their logos.
Yeah.
It's often meant to convey trust, stability, and reliability.
Like, blue is the color of dependability. It makes you wonder about the intentionality behind the colors that we surround ourselves with every single day. But do you think there's any truth to the idea that different cultures perceive color differently?
Oh, absolutely. Culture plays a huge role in how colors are interpreted. Take white, for example. It's often associated with purity and weddings in Western cultures, but in some Eastern cultures, it symbolizes mourning.
Wow, that's a really powerful example of how a single color can hold such different meanings, depending on their cultural context. It makes you realize how important it is to be aware of these nuances, especially in our increasingly globalized world.
Yeah, it's a reminder that color is not just about aesthetics, but also a powerful form of communication.
For sure. Our source mentions some pretty curious facts about color, too. Like, did you know that the color pink technically doesn't exist in the visible light spectrum?
It's true. What we perceive as pink is actually a combination of red and violet light frequencies. It's our brain that interprets this specific blend as the color pink.
So pink is more of a perception than an actual wavelength of light.
Pretty much, yeah.
I wonder why our brains evolved to interpret those specific frequencies as pink.
That's a great question. Some researchers believe that our sensitivity to pink hues might be linked to our evolutionary past. For instance, the ability to detect subtle variations in red tones could have been helpful for identifying ripe fruit or recognizing changes in skin color that signal health or illness.
Interesting. So there could be a deeper evolutionary reason behind our perception of color.
It's possible.
Our source also mentions invisible colors, like ultraviolet and infrared. What's that all about?
So the rainbow of colors that we see, the visible light spectrum, is just a tiny sliver of the electromagnetic spectrum. Beyond our range of vision lie colors like ultraviolet or UV and infrared or IR. We can't see them, but they have a big impact on our world.
Yeah,
Think about how UV radiation from the sun causes sunburns,
right.
or how infrared is used in thermal imaging.
It's wild to think that there's a whole world of color that exists beyond what our eyes can perceive.
It really is.
And speaking of colors with a hidden history, our source mentions how the color blue was once incredibly rare and valuable.
Oh, that's right. Blue pigments were so difficult to create in ancient times. The Egyptians, for example, had to develop really complex methods to synthesize blue pigments for their art and jewelry. It was a color associated with royalty and luxury.
Wow. It's amazing to think about how the perception and availability of a color can change so drastically over time. Okay, last intriguing fact from our source, the Stroop effect. What is that exactly?
The Stroop effect is a really fascinating cognitive phenomenon. It demonstrates the interplay between color and word recognition. Imagine seeing the word red written in blue ink.
I have a feeling that would make my brain do a double take.
Haha, exactly. It takes us longer to name the color of the ink because our brain automatically processes the word's meaning, creating a kind of cognitive interference.
So it shows how our brains are constantly trying to make sense of the world, even when we encounter conflicting information.
Yeah.
Now, onto a color that sounds like it's straight out of a science fiction movie, Vantablack. Our source describes it as one of the darkest substances ever created.
Vantablack is remarkable. It absorbs almost all visible light, making it appear as close to a black hole as we can imagine.
So it's like looking into the void.
Yeah, kinda.
How does something like Vantablack affect our perception of color?
Well, Vantablack really pushes the boundaries of what we consider black. And it highlights the fact that color perception isn't just about the wavelengths of light hitting our eyes. It's also about how our brains process and interpret those signals. Lighting, surrounding colors, even our emotional state can influence how we perceive a particular color.
You're telling me that our perception of color is not as objective as we might think.
That's right. There's a phenomenon called color constancy, where our brains actually adjust our color perception to remain relatively consistent under different lighting conditions. It's like our brain has its own built-in Photoshop, constantly recalibrating to keep colors looking stable.
That's incredible. It seems like there's so much more to color than meets the eye.
Yeah, it really makes you appreciate the complexity of something we often take for granted.
It really does. It speaks to the brain's incredible ability to process all this sensory information and then create this coherent experience of the world.
It's amazing, and so much of what we've discussed today highlights just how much our brains are involved in shaping our perception of color. Absolutely. And that brings us to another pretty fascinating concept. The idea that our perception of color might not even be universal.
Oh, wow.
Imagine a world where people experience color in completely different ways.
That is mind-boggling. Are you talking about conditions like color blindness?
Well, color blindness is one example,
Mm.
but there are even more extraordinary cases. Our source mentions a condition called synesthesia, where people experience a kind of blending of their senses. So for some people with synesthesia, sounds might evoke specific colors, or tastes might trigger visual patterns.
Wow, that would completely change the way you experience the world. Do scientists understand what causes synesthesia?
The exact mechanisms are still being researched, but it's thought to involve unusual connections between different sensory areas in the brain.
Interesting. So as we wrap up our deep dive into the world of color, what are some key takeaways that you'd like to leave our listeners with today?
I think the most important takeaway is that color is so much more complex and multifaceted than we often realize. It's not just about aesthetics. It's about science, psychology, culture, and perception. Color influences our emotions. It shapes our understanding of the world. It even reveals the intricate workings of our own brains.
It's really amazing to think about how something we encounter every single day can be so full of surprises and hidden depths.
Absolutely. And hopefully this deep dive has sparked a sense of wonder and curiosity about the world of color around us.
Definitely. We've journeyed from the basic rules of color to the mind-bending concept of invisible colors. We've explored how our brains play such an active role in shaping our perception of color. It's been really illuminating.
And remember, there's always more to discover. So the next time you see a vibrant sunset, or you're admiring a colorful piece of art, take a moment to appreciate the complex interplay of science, psychology, and perception that makes it all possible.
That's a great point. Thank you for joining me on this colorful deep dive.
My pleasure. It was fun.